In this video, we're going to do example 6.4.5. So let A be this matrix here, and we are asked to evaluate the determinant of A along two different rows or columns. So we're going to start out by doing the determinant along row 2. So if we go along row 2, well, we need our grid of plus and minuses, so we'll start with the plus in the top. We'll alternate, so we get plus, minus, plus, minus. And so this is a 4 by 4 matrix, and so we have no choice but to do this cofactor expansion. We don't know another method to evaluate the determinant of this 4 by 4, so we start with the cofactor expansion. So along row 2, we're going to have the determinant of A is, well, it's going to be plus 0 times, and I don't even really care what that minor is because it's going to be multiplied by 0, so I'll just leave that off, minus 2 times, and then I need the minor. That's now going to be a 3 by 3 minor, right? We have the entry here with the 2, and so we're going to have 1, 0, 2, 3, 4, 2, minus 1, 0, 2. So 1, 0, 2, 3, 4, 2, minus 1, 0. What did I just say? Minus 1, 0, minus 2. So there's our first minor, and then working our way across the row, we need plus 0 times. So again, I'm not going to write it because we don't care what that minor is. It's going to get multiplied by 0. And then lastly, minus 1 times. So minus 1 times, and delete that row and column, and we have 1, minus 1, 0, 3, 1, 4, and minus 1, 3, 0. So my first step of cofactor expansion has given me 2 more determinants to evaluate. It could have given me up to 4 more to evaluate if I'd chosen, for example, if I'd chosen row 2 or column 4, then I would have had even more. I wouldn't have had these zeros here. So that's something that's nice that we should sort of take stock of. We've saved a little bit of work here by choosing rows with zeros. And we'll look at that in just a second when we make our next choice. So this minor here, this is now a 3 by 3 determinant, and we have choices. Now, for a 3 by 3 determinant, we can choose to evaluate this with cofactor expansion, or we can do Sarris's rule. So I'm going to do one of each because I can, but you can choose to do them both the same way, or one of each, or it doesn't matter which one you choose. So I'm going to do the first one using cofactor expansion, and I've just noticed that I've saved myself some work with zeros, and so I'm going to choose row or column with the most zeros to save the most amount of work, and that would be column 2. So I'm going to do column 2, which means I need a grid here, plus, minus. So minus, plus, minus going down column 2. And so I'm going to have, I can leave off this 0 here, minus 2 times, and I'm going to do a cofactor expansion going down column 2. So if I'm just going to write everything, minus 0 times, again, I don't care what that minor is, plus 4 times the minor where I delete the row and entry of the 4. So 1, 2, minus 1, minus 2, 1, 2, minus 1, minus 2, and then lastly minus the 0, so minus 0 times some minor. Plus 0, and then minus, I'm going to come back to this in just a second. This one I'm going to do with Sarris's rule. I'm going to do with our basket weaving triple diagonal method. So I've got minus, minus, so I'm just going to say plus the determinant, and now this time I'll rewrite this one, rewrite the columns using Sarris's rule, so 1, 3, minus 1, and minus 1, 1, 3. All right, so now let's go back here. This is minus 2 times, open a bracket. These zeros I'm going to leave off, and so I have times 4 times, and now I have to do the determinant, which is going to be AD minus BC. So I have minus 2 minus minus, so minus 2 plus 2. So all that work, and that's all just going to go to 0, but that's what you get sometimes. So then plus here, and then we have to do these triple products. So going down here, I'm going to get 0, double minus, so plus 4, plus, and that's multiplied by 0, minus, and then up here, I'm going to get another 0, and this is going to be plus 12, and lastly another 0. All right, so what do we have here? Minus 2 times 4 times 0, so that's all just going to be 0, and then plus 4 minus 12, and so we get 0 minus 8. So minus 8 is the determinant that we get along row 2. Now, using our newly found strategy of choosing lots of zeros, then there really is an optimal next choice. If we're allowed to choose any 2 rows or columns, I'm going to choose the one here with the most zeros for my next choice, which means I'm going to go down column 3. So column 3, I need my grid. Again, I have to start with cofactor expansion because it's a 4x4. So plus, minus, plus, minus, plus is already there, and minus. So going down here, again, just for completeness, I'll write it's plus 0 minus 4 times some minor. And then I'll just finish up the row, plus 0 minus 0. And I've left myself lots of space because I'm going to do this one by Sarris's rule, although I could choose to do cofactor expansion whatever I want. And so if we delete the row and column of this entry, we have 1 minus 1, 2, and then 0. I always have trouble picturing this. So 0 to minus 1, 0 to minus 1, and lastly minus 1, 3, minus 2. Boom. Okay, so we copy those first 2 columns, minus 1, 2, and 3, right? You could do cofactor expansion. Oops, I forgot to write determinant of A equals. Well, let's just get that in here. Determinant of A equals. And then finally, so we have minus 4 as our entry, and then we're going to do our triple product here. And so we have a minus 4, 3 minus these 2 products. We have again a minus 4. This is going to give me a minus 3, and this one gives me 0. So what happens? We're going to have minus, so plus 7, or minus 4 times 2, which is minus 8. And so we get the same answer using either row or column that we just chose, and that's what we should expect, right? Because that's what the Laplace expansion theorem told us would happen, that no matter which row or column you choose, you're going to get the same answer. Now, so we noticed a little something, which we're going to write down in our takeaway, and that is that even though the value is going to be the same, that doesn't mean that all choices are equal, right? You will get the same value no matter what row or column you choose, but the most efficient choice of row or column, if you are doing it by hand, is to do the row or column with the most zeros so that you save yourself a little bit of computation, a little bit of work. And the second bit of the takeaway is when evaluating the determinant of the 3x3 matrix, like as we saw up in the first when we did row 2, we have a choice of methods. And so a 3x3 matrix, we have the rule that we found at the beginning, Sarris's rule that we defined at the beginning as the determinant of the 3x3 matrix, or cofactor expansion. With a 3x3 matrix, you always have that choice of methods. In the next video, we're going to go on to subsection 6.4.3 and see the determinants of some special kinds of matrices.